forgot I didn't. So we are talking about, oh good, there's a color that's good. And that's not a very good color. This one worked. This one didn't. Sorry, I wasn't thinking about the colors. Okay, that sort of works. Okay, that's sort of okay. All right, so graphing systems of inequalities. It's just like graphing systems of equations with just a couple exceptions. When you're doing systems of inequalities, instead of an equal sign, you have a greater than sign or a less than sign, or you have a greater than sign, greater than or equal to sign, or a less than or equal to sign. Okay? And so that alone causes two problems, or makes two differences from systems of equations. And the two things are, number one, when you draw your line, that line has to be either solid or dashed. And you have to know which one it is. If it says just plain old greater than, then it's going to be a dashed line because it does not equal the line like it does on an equation. It doesn't equal that line, so you can't make that line solid because that would mean it equals that line. You have to make it dashed. So if it is greater than or if it is less than, you're going to have a dashed line when you draw your graph. If it is greater than or equal to or less than or equal to, that means it's greater than or it's less than, but it's also equal to. And if it's equal to, we can make the line solid. So when you draw the line, you'll draw it solid. So that's the first one, and I think most of you got that down pretty much, right? Isn't that fairly clear? So one way I remember is if I see a line underneath it, I just know, oh, okay, it's going to be a solid line. If I see no line underneath it, it's going to be a dashed line. Right? I just use that as my thing. Now, the other thing is we actually are going to have to shade one side of the line. And so that's the other issue. And the third, actually there's a third thing too, is that in systems of equations, you have exactly one answer. It is exactly a point where those two lines cross, right? But with systems of inequalities, you have an infinite number of answers because it's below the line or above the line, and it's everything below the line or above the line. And then when you have two equations, you've got to see where they both are true, where they both intersect each other. And it's usually a whole section, and it goes on forever, and ever and ever and ever and ever, right? So therefore, it's going to have lots of answers, like infinite number of answers, right? Does that make sense? Those are the differences. So that's why these are a little more complicated, but they're not that bad. So first, I will draw my graph. Okay, here we go. X, Y. Now, I'm going to use blue for this one. Blue. All right, so I'll do that one first. So this is in slope-intercept. I can always use a t-chart if I want, but I don't want to. But I can, always. For all equations that you're learning in Algebra 1 or Algebra 2, you can always use a t-chart. Oh, thank you so much. Sorry to do that. But because it's in standard form, I'm going to just use x and y intercepts, right? So I'm going to pretend for now that it just says equals. Because all I'm trying to do is find my points.
Didn't we have this lecture already?
I talked about this the other day, but I didn't do a lecture on it. I mean, I didn't actually videotape it. Oh. That's why I'm just being a little thorough. but yeah, I'll probably go relatively quickly since you guys know it. But this is standard form. I'm going to assume it's an equal sign for now, just to find my points. So to find my y-axis, or my y-intercept, excuse me, I make x equal to 0. And so negative y is equal to negative 5, and positive y is equal to positive 5, right? Because I could multiply both sides by negative 1. So negative y would become positive y, negative 5 would become positive 5. So y is 5. So I go up here, 1, 2, 3, 4, 5, and I put a dot. Okay, now to find my x-axis, I'm going to make y 0. So 5x is equal to negative 5. Divide both sides by 5. X is equal to negative 1, right? X is equal to negative 1. Here we go. Boom. I'm going to put a dot there. Now, is it going to be a dashed line or a solid line? Dash. So I'm going to, oh, I have a ruler today.
Oh my.
This is great. So it's going to be a dashed line. So here we go. So all right, and this line goes on forever and ever. No, never ends. All right, so that's my first line. Now I've got to figure out my shading, right? So I'm going to choose an easy point that is not on that line. Fortunately, 0, 0 is not on the line, so I'm going to use 0, 0. So 0 minus 0. I'm going to replace x is 0 and y is 0 at this point. So I'm going to replace the x with 0 and the y with 0. So that all equals 0. So 0 is greater than negative 5. Is that true or false?
That is true.
That is true. It is bigger than negative 5. Therefore, I'm going to shade towards that point, towards 0, 0. I'm going to go at an angle, and I'm going to just shade. This is where it's kind of important to be very neat when you do this. All right? As best you can, because it'll make it so much easier to see the answer. So it just takes a little while to shade, but I shaded it. There we go. So I did my first one. Now I'm going to do the next one. I really feel like red. I don't know if I have a red. I do. Let me see if it works. Oh, I do. Yes. Okay. So this is going to be red. All right, my second one. All right, so again, I'm going to use it's in standard form. So the easiest way is to use x and y intercepts again. To find my x-intercept, I'm going to make y 0. Negative 2x is equal to 6.
Negative 3.
So divide by negative 2, x is negative 3, right? So x is negative 1, negative 2, negative 3, put a dot. And then I'm going to find my y, make x equal to 0. 3y is equal to 6, so y is equal to 2, right? Everybody with me? Y is 2. So I'm going to go up here and I'm going to put a dot right here. Y is 2. And now I'm going to draw my line. Is it going to be solid or dashed?
Solid.
It's going to be solid because it has the line under there that tells you it's going to be solid. All right, so here we go. We're going to draw this one. And it's going to be solid, so that'll be easier to draw. Okay, there's my line. Okay. And I put my arrows at the end because I want to remember that they go on forever. And then I've got to figure out which way to shade. Well look, it doesn't go through 0, 0, so I could choose 0, 0. That'd be easy. So I plug in 0 for x and 0 for y. That just equals 0. So 0 is less than or equal to 6. Is that true or false?
Yeah, true.
That's true. So I get to shade towards that again. Now, if I shade like this, do you see the problem? I would be messing up the other shading. It would be really hard because my red marker would go over the blue and it would erase the blue and it would turn it red. And then I would have a hard time seeing where it intersects. So always crisscross your shading, right? So since that's going that way, I'm going to go a different way. I'm going to go probably this way. So I'm going to shade going like this. And it's like this. Okay, boom, boom, boom. I don't like to go straight up and down or straight to the left and right because then it makes it hard to see my x and y axis, right? You see what I'm doing? So it's always going to be diagonal shading. At least that's what I choose to do. And now it goes on forever and ever like this. All right. Now what I have to do now is I have to look. These lines, the two main lines that I drew, are my boundary lines, and everything. I'm looking for where there's double cross stitching, right? Or whatever, where the shading is crossing each other. So basically, the area is going to be from here over and from here over. Does that make sense? And it goes on forever. So this is my section. If I was going to draw it, I think probably the easiest thing is to just draw, lots of lines in the section so I can really see you know, that it's all this section here. It's all this. And it goes on forever and ever. So I can tell it's definitely not here, even though there's shading here. There's not also the blue shading here. And there's blue shading here, but there's no red shading, so it's not here. It's only going to be there and there, right? So if I asked you to name a point that is a solution to this,
You could say 0, 0.
you could say 0, 0, because that's in the middle of one of the shades, right? Of both of the shades, right? So that's basically it. Sometimes they're easier than others. Sometimes, you know, sometimes you'll graph them, and it's just this little section right here, right? And it's really easy because you can see it doesn't this is a very large answer. There's a lot there, so it's easy to sort of get a little lost when there's so much of an answer. When it's just a tiny little wedge, it's often easier to see. Is that pretty clear, though? They're not that hard. It's just you have to graph them. You have to remember either dashed or solid line, and then you make sure you shade the right side. Because if you shade the wrong side, you've gotten a lot wrong on that problem. Like, none of the answers will be right. You know what I'm saying? There's a million answers, right? And if you shade the wrong side of a line, you just got a million answers wrong, right?
Oh,
in essence.
I got infinite.
So, and I take a million points off for that, right? Because it's just, it's fair, right? That's what I know. Okay, so that's it. So that's graphing systems of inequalities. I'm going to just stop this.